Hey guys, welcome to my video on dividing polynomials by a polynomial. In this video, we will cover how to divide a polynomial by a monomial. Alright, so let's begin. Alright, so here's three different ways that you can write division. You can write it by a group, polynomial divided by a group multiplied by the group of x plus 3 raised to the negative 1 power, because as you know, negative 1 means to find the inverse, the reciprocal, right? So 1 over x plus 3 would be the reciprocal, and that means division. And you can also write it as a fraction. So polynomial divided by a polynomial written as a fraction this way. So all three ways mean the same thing, and that is to divide. All right, so let's look at some examples. All right, so our first example is to divide this mess divided by this monomial. So this is a polynomial, 12km to the third power minus 20k to the third power m plus 18m squared divided by 4km. So we want to divide this by writing each term of the polynomial as a fraction with a common denominator. So we're going to start with the first term, 12k m to the third power divided by 4km. Right, minus 20k to the third power m divided by 4km plus 18m squared divided by 4km. Okay, now we're going to simplify each fraction. So I know 12 divides by 4 evenly, and I will get 3 whole if I divide. I know my k and my k will cancel out, and I know m cubed divided by m to the first power is going to be m to the second power. Please refer to your quotient power rule. Quotient rule means to subtract your powers when you're dividing. M cubed divided by m to the first power. All right, now don't forget to bring down your sign, minus sign. 20 divides by 4 evenly, and we will divide that, and we will get 5. K to the third power divided by k to the first power is k to the second power. And then my m here and my m here will cancel out. Okay, let's continue our last term. Plus 18 divides by 4 does not divide evenly, so I can reduce it by 2. 18 divided by 2 is 9, and 4 divided by 2 is 2. All right, so that's where I'm going to get my 9 over 2 from. Okay, now I want to talk about this k here in the denominator. Notice how there's no k in the numerator to cancel out, so it stays in the denominator. Okay, now we have m squared divided by m to the first, which is m to the first. So if it's a positive m to the first, then it stays in the numerator. If it's negative, if it's m to the negative 1, then it stays in the denominator. All right, so nothing is like, so that's your final answer. All right, let's move on to our next example. So our next example is this polynomial divided by this monomial. So we'll do the same exact thing that we did by putting everything with the same common denominator. Okay. And finally, my last term divided by 6m to the third power. So let's reduce our fractions. 12 divides 6 evenly, now we'll get 2. Okay, m to the 12th power divided by m to the third power is m to the 9th power. All right, carry down your sign. 18 divides into 6 evenly, and I'll get 3. M to the 6th power divided by m to the third power is m to the third power. Please do not confuse division. Don't divide 6 divided by 3, it is subtraction. Okay, same thing here. Don't divide 12 divided by 3, it is subtraction. It's not division. Okay, all right, now 24 divides by 6 evenly, and I should get 4. Okay, and then this is m squared divided by m to the third power. So remember what I said before, right? We are subtracting our powers. It becomes m to the power of 2 minus 3, which is m to the negative 1 power, which you have to apply the rule for that, which is negative exponent rule. That's equivalent to 1 over m. So this is technically 1 over m. Okay, so now we want to reduce that. So we want to make sure everything is written correctly. It's 4 divided by m. That is your final answer. Okay, let's look at our last example. Our last example is this polynomial. Technically divide by this monomial because it's being raised to the negative 1 power. Okay, so I'm going to do the same exact thing as how I started. The first term divides by the denominator. Second term divides by denominator. And the last term divides by the denominator. Okay, let's reduce. So 27 and 6 divides by 3, and you'll get 9 over 2. All right, so that's 9 over 2. Our a's here, a to the first and a to the second, divide. I'll get a to the negative 1, and I know anything to the negative 1 power or negative power belongs in the denominator. All right, my b's will cancel out and my c's will cancel out, so that's easy. All right, next, plus 9 over 6 divides by evenly. So, no, sorry, not evenly, but what I mean is it could reduce by 3. So that becomes 3 over 2. All right, that's where I'm getting my 3 over 2 from. All right, same thing here, a to the first and a to the second. Division will lead an a in the denominator. My b and my b will cancel out, and since c here is in the denominator, it stays there. Okay, 10 over 6, so 10 divided by 6 reduces by 2, so that gives me 5 over 3. Okay, so that's positive 5 over 3. All right, a to the first, a divided by a to the second is the same thing as what we had before, a in the denominator. There is no b to cancel it out and stays in the denominator. And my c's will cancel out. All right, there are no like terms here. So that is it. That is your final answer. All right, thank you for watching this video.